Oh, you caught me. I was ready to go. Hi, Jackson. How are you today?
Hey, good morning. Enjoying that interlude music.
I mean, we got to do whatever we got to do to keep going today. It's been, as you could probably imagine, we've had a lot going on with everything out in the world, plus getting ready for this amazing presentation and getting up early to make sure that, got to watch Zach present. So hopefully everybody is here doing well. This is our second session, and I'm just now waiting. I'm ready to share my screen, so let's get that up there. Perfect. So welcome to Particles Prototype to Production, How to Get Your IoT Product to Market Part 2, another series in this masterclass series that we're offering today for IoT. So we're, again, the focus of this session is really how to effectively launch your particle-powered product. So this is a little bit more of an expert manufacturing session where we'll have a concerted focus on managing the risk in the NPI process, and a more advanced look at manufacturing in particular with a particle solution. So don't forget to join the discussion board and again, refer a friend, like, hey, who doesn't like money? All right. So we're going to go ahead and talk a little bit more. So if you weren't here in the first session, my name is Jerry Miller. I'm the Director of Manufacturing Operations at Particle. I've been here for about 2 years now. I've got some previous experience at a little fruit company down the road. But this has been my life in operations of getting products to market. Sorry if I'm a little tongue tied today. I'm just really excited. Ethersam. So my team is responsible for basically anything from raw materials to production and getting our products to our customers. So I do, of course, work a lot in China with our manufacturers and our extended supply base. So it's a really exciting time to be here. And I'm very excited to introduce Tim Jackson, who I've been working with here for the last couple of years, and Tim, one of the things before Tim talks, I'm really excited about is this Spectra allows us to have some of the amazing talent that we have at Particle really uplifted for the world to see. I get to see these people on a day-to-day basis. I know how amazing they are, so I'm so excited to have Tim, who is an amazing person. Who, mind you, I've been working with for 2 years. I still don't know what you do. So can you tell me what is a system engineer? What is a systems engineer, Tim?
Yeah, so systems engineering is this sort of marriage of different systems, whether it be high voltage, low voltage, sensors, environmental constraints, and marrying these all together to create a robust product that performs well.
Great. Yeah, I was telling you, I've seen like 5 titles for you. So this is the one that I think that now I get it. So thanks for explaining, Tim. And we're looking forward to this. So let's go on. And if you were in session 1, you'd know that I have a love of quotes. And I think by failing to prepare, you are preparing to fail. And the reason I like this quote is it is important to understand that, like, if you don't plan and you don't prepare, it's gonna go bad. This is hopefully a good session to kind of prove out why planning matters on top of everything else that we've talked about today. So let's first talk about managing your risk. Really here, this point is to define the product and the problem. How many times have you seen something, you're like, what does that do? And why are we doing it? And then you see it on the market, you're like, what is that? So you want to make
Every
sure
day.
I think Zach actually, Zach mentioned this in the keynote today, right? Around, how many IoT products that we saw that were like, what, who, somebody paid for this? So we want to make sure that we're defining the product, we're reducing unforeseen cost, and we're minimizing redesign efforts. So that's really here a good focus of this session. I mean, Jackson, is there anything here that you would sort of kind of highlight that is really important about managing risk?
Yeah, it's really key to define the problem and understand what am I trying to solve, and make sure that your design is meeting that need.
Yeah, great. So I want to get to the meat of this. I realized in my last session we did a lot of stuff, and Tim, I think, has a lot of great content, but I want to rehash a little bit. NPI, new product introduction. So if you weren't on session 1 and you're just joining us this time, we really focused on covering these critical stages of NPI. Pre-prototyping, where you define the functional requirements of the product and its performance. Once you have a good understanding, again, this is like your roadmap, right? Knowing where you're going. Then you have to, once you feel good, you feel confident, that's clearly defined, your team is bought off on that, then you I would say escalate, but then you graduate to the prototyping phase, where you test that design, meets functionality. You can do a few unit runs. Once you feel, you're starting to, crawl a little bit, now you're ready to sort of maybe toddle through life, and you graduate to the engineering validation test. Here, you're testing the core design and function and features. So you're going to build, maybe 20 or 30 units. You're going to send some of these units to some customers. You may send them to some partners to test. Here, you're really making sure that your engineering team is really, and your product team is aligned and validating and making sure that what you've designed is actually, going to be able to be produced. You do design forward.
Iterate.
Yeah. What I mean, Jackson, as you think through some of these processes that I've mentioned thus far, is there anything that comes to mind as very important to think about in these stages?
Yeah, in the prototyping, you can grab anything off the shelf, slap it together. We've seen shoestrings, some bubble gum wrappers, whatever it takes to make it work. And then in the EVT stage, you have to actually sort of start to look at how to design the real product and move in that finished direction. And as Jerry's bringing the point, the EVT is the time to iterate and really make sure that it's perfected before you move on from this point.
Yeah, and as I mentioned before in our previous session, we did a lot of we went through. We actually developed our whole asset tracker, launched that in COVID, with no trips to China. We had to do this, and so we had a lot of time to reflect then on our actual process. And we've actually gone back and redesigned our MPI process to be flexible and rigorous. And I think that process and making sure that it's flexible and rigorous allows for risk mitigation. So this is the reason why we're kind of harping on these stages and what happens in these stages, is because this allows for a very structured approach to developing your product and getting it to market. Because when you do, let's say, when you're ready to graduate from engineering validation test, EVT, to design validation, now this is your last stop on the road, right? Before you're ready to like really jump off and hit the highway and go, 1,000 miles an hour, right? The design validation, you validate the design and you can manufacture at scale. So this is, again, your last turning point before you really dig in and go forward. And again, all of these previous four, pre-prototype, prototype, DVT, these are engineering driven, production phases, the stages. PVT goes to production, goes to my team, operations, where you actually determine whether you're ready for mass production. So it's kind of like in the car scenario, you're really opening up the engine here before you really take it out for a full spin.
How are we going to build it? How's it going to come together in the quantities of thousands?
Yes. Yeah. So, again, we recommend doing a PVT before you do a ramp or a general availability, because this is really like your chance to work with the manufacturer, understand can they do what we need them to do at scale. So this is really, I think, a very important piece here to note. And really why we wanted to do this is we wanted to get to some of these key risks. If you don't follow through and think about it, there are really important risks and potential issues that may be an outcropping of what happens in the MPI. An undefined project scope could be, loss of time, money, and customers, right? If you don't know what you're if you don't know what you're trying to produce, I mean, you really could lose like everything. You lose your shirt on your back. So we don't want you to do that. The next one, and Jackson, I want you to kind of jump in here, is unclear roles and responsibilities. What are some of the things that our team, our folks here should be aware of as a key risk of unclear roles and responsibilities?
Yeah, this is a key point to look at. You want to make sure you understand what are your strengths in-house. What are you really good at? Are you able to write really solid firmware? Are you able to make sure that your material is going to fit into the environmental conditions and withstand it? So you kind of look at who's going to be responsible for what parts of it, and what do I need to outsource? Do I need to hire a firmware team to write really solid code?
Mm-hmm.
Make sure that you define that roles and responsibilities so that you're set up for success in-house and with your outsourced teams.
Yeah, and I think this is really good. And speaking of outsourced teams, one of the things that you're going to be doing is working with suppliers and raw materials, both plus your contract manufacturers. So making sure that you're thinking about manufacturability and vendor selection here. If you don't do this right, you could lead to this could be longer than expected lead times, lower than expected yield, and yield is my like baby. Like I want like 100% all the time. That's not possible, but you want to make sure that you're picking the right vendors that it's going to enable you to meet yield projections that you have, so that you don't have all these incremental costs later on down the road that you weren't expecting.
And if I can add a point on the yields for the customers or for people out there, yield is kind of like this. He's achieving to get 100. He wants to have everything that's produced comes out is really good, but quite often there's some devices that need to be reworked or fixed or repaired for one reason or another. And so
yeah, and yield, just for those of you who are not as intimate with the manufacturing, it's the thinking about it in the that there's if you say that there's 100 sets of raw material that go in, you want 100 sets of end product that come out. That's not normal. Usually you're going to have some sort of what we call attrition. So usually you put in 100 sets, and the goal here is in the electronics industry is 96 to 98%. Yield. My target yield is always 98%. For enclosure products, you're going to look at a yield that's probably closer to 94 to 95% over time. But initially, through these NPI stages, they will be very low, and that's okay. That's okay. That's normal. They're supposed to fail early, as we learned in session 1. So we have a question for the team as we move forward. For the team, I think of you as my team. I know Jackson's on my team. Have you developed a particle powered product? So Alexis in the back, can you please launch that for me? And let's see what we have. Hopefully, we have a mix of yes and or on its way. And so thanks, Alexis. So this is something. So Tim, as we're thinking about this. What are some things that you're excited about talking about over the next few minutes from developing particle power products?
Yeah, just ensuring that people put in the thought early and into all of the considerations that need to take place when designing a product. If you put in that early thought, you run through these early exercises, you're destined for great success.
While we're waiting for the results, let's go ahead, because I want to be mindful of time. So now we're moving into the deploying with particle coffee chat on best practices. So let's focus first, Tim. When we are deploying with particle, what are some of the upfront design considerations that our folks here need to be aware of?
Yeah, it's good to take a look at what is my use case. What am I trying to achieve here? You have to kind of choose how your product is going to fit into this market. It's going to solve what kind of problem, and in order to do that, what kind of data would I need to capture out of the field, or to sense and to be able to display, or thinking about it from the device itself all the way through to the customer using that information, or the customer, the end users. And so looking at your product requirements doc, this is one that's quite often overlooked by a lot of customers, and putting in this extra time to sort of clearly define the product requirements. What kind of power requirements is this device going to have? What kind of data requirements? What kind of ingress protection and ability to survive harsh conditions? Taking that time to think about these are all of the bars we want to meet and all of these different boxes to check, then at least gives you a nice roadmap or a guideline for your ability in being able to design a product. Without this, it's kind of like partially designing a car and then later on realize, oh shoot, we forgot to include the steering wheel. Oh, we forgot the tires, and so you're left high and dry.
Yeah. Let's moving on. Like what around environment? I see on the slide we talk about environmental conditions. So why does environment matter?
Yeah, that can play a huge factor. Are you placing this say up in the subarctic circle in extreme conditions where it's very cold, or in the deserts of Australia where it's extremely hot? we need to take these into consideration as these can affect not only the material that the enclosure is made of, but also the color of it. Having a black enclosure can raise those temperatures quite significantly.
Yeah,
And
it's not like you can put a fan in there like on your your PC or your MacBook or something like that, right? Like there's just no space for a lot of this stuff.
yeah, that is true. Not to mention fans suck a lot of power, so you have to how much space am I going to have to have the batteries that I need to get the lifetime I need out of it, or how can I regenerate electricity to keep those batteries topped off?
Yeah. What about cellular reception? What tell us more about the antenna placement?
Yeah, this is a big one. A lot of people want to get the best reception they possibly can. And cellular is an interesting technology in that it can operate quite effectively on very little reception. Moments of being connected can blast out quite a bit of data. And so there's things to consider when placing your antenna. That's going to be the largest impact you have on getting good reception. Getting that antenna up as high as possible and making sure that it's got good line of sight to the nearby cell towers.
Higher to the sky. All right. So
That's right.
one last thing on this slide about around expertise. I think you have a very strong point of view on this.
Yes, that is to basically leverage your strengths, and where you're weak. Don't spin your wheels and try to do it in-house to save a few bucks, because it'll come back to bite you later on. It's good to hire that team that can stand up that cloud architecture to be able to ingest the data and use AWS to its fullest potential. For example, it's key to outsource where you need help, and that will just speed your pathway to product release.
Great. So let's move forward. I think we get some common questions for customers. Given our time constraint, maybe cover like which one you think is the most common question that we get.
Number one, let's see. I get to choose here.
Choose your own adventure.
I personally, I love batteries and chemistry, and I have a lot of customers coming to us and say, I need to last this amount of time out in the field, and I'm capturing information. And so a lot of times people will want to do some sort of sleep mode, and that is where they put the device to sleep for a period of time. They wake up, they sense the information, they publish the information, and they go back to sleep. You have to watch out in those scenarios that how critical is it to get that data out? Because if, for example, the device wakes up and at that moment in time it doesn't have a connection, will it retry? How many retries will happen? And these all will play a factor on the battery. And I love to look at chemistries personally of batteries, because you can get quite a bit more power by changing the chemistry a little bit. Also in extreme weather conditions, up in the Arctic cold, say North Dakota in the winter, you may have to change the chemistry of your battery a little bit to get the power delivered out of the battery in those lower conditions, whereas some certain chemistries cannot handle those lower extremes.
Yeah. Good. Well, I mean, particle folks are always around to help. We have our community forums where you can join to help answer these questions. You can also go to our website, and we have a tutorial section. So we try to, again, get all the hard stuff out of the way for you. If you need help, we're here to help you along the way. So our last sort of point here, I think we talked a little bit about antenna placement. So let's close the session out really on cellular reception and some very interesting points around that. So tell us a little bit more about this.
Yeah, so people will use some of these interesting open source tools to be able to leverage the known information about what's out there in order to ensure success of their device. So if you go and you have a location that you're going to be placing a device, a lot of times people will use the MCC, MNC website to identify, okay, who's the carrier that owns the antennas that my device is operating on. And the open cell ID will show you exactly who's on the towers nearby your device in those locations. And you can use a powerful tool called an RF meter. They're about $300 or $400, but you can even rent them these days. And that will allow you to connect the antenna that you're planning to use and its cable to the RF meter in the location it's at, and actually take a measurement to know Am I on the edge of connection, or do I have it? But a lot of times people will just throw a device out there, get it in the
Yeah.
field, see how
Yeah.
it operates.
So one sort of question I have here, and is we all have these dead spots. So I live in the Bay Area, of course. Driving across the bridge, the Bay Bridge, or coming up 280. There's these just two cell towers. They're not quite close enough, and there's a gap, and that's inevitably the place where your device needs to go, is right in that gap. What is something that our customers and our team out here, broader folks, could do to kind of help mitigate that gap as best as possible?
Yeah, so if there are moments of periods where your device is not able to connect, some techniques are typically to do retries and to lengthen the amount of time in between each retry, to sort of not just retry for a period of time when it's dead. And another thing would be to, if you have a device that's really problematic, would be to change the antenna type. A lot of antennas are omnidirectional; they go in all directions. But some that are more powerful are Yagi antennas, and those can be aimed from the location of the device at a specific cell tower. And so, by their, they cost a little bit more. And as it was mentioned in the previous talk, certification would have to happen again, simply because the antenna form factor and gain will differ on the Yagi antenna. And so these are things to consider. However, it's not very often you'll find a black hole, where the device is sitting there and has zero reception. There are places in the US, and in those scenarios, the Yagi antenna is your best bet in punching out.
Great. All right, so we're into the question phase of this topic. So thanks, Jackson, for those I think very important points that we covered. So I'm going to take some questions from the chats. Llewellyn asks, "What are your?" Oh, sorry, no, that was sorry. Bill, I cut Bill off first. Bill wants to know: is cellular reception impacted by other nearby components, e.g., power supplies or motors?
Yes, so cellular antennas can be affected by anything metal nearby, and electronic components are also metal. And so the orientation of your antenna can have an effect on how it's placed with, say, your cellular antenna, or sorry, your electronic board. And so placing your antenna in a parallel fashion as opposed to a diagonal fashion can have a dramatic effect on the performance of that antenna.
Good, great. So thanks, Jackson.
Bodies of water. Sorry to finish that out. Hills, trees, cement, all sorts of things can wreak havoc on a cell reception. So like as I said, get that antenna up as high as possible, or device, and that'll help.
I actually, thinking about Tracker One, I feel like our solution there is pretty strong in this, because we've done a lot of testing in cities and around different areas, so it is possible to develop something that can get through all this, but it takes a very rigorous design process and execution to ensure something like an asset tracker solution. But the good news is we have Tracker SOM and Tracker One for everybody to kind of give you a head start on making sure you have a product that is enabled to meet all those all those different interference patterns that could happen for getting reception. Another question we have is, can you speak to the risk liabilities of using LiPo batteries, shipping and charging? I'll talk about shipping, you talk about charging.
Yes, so charge state on LiPo batteries for shipping needs to be at 40% or less. You don't want a fully charged battery when shipping in general. And so typically people will also disconnect that battery from the electronics during shipping and then reconnect on the other side. If that's not possible, then a lot of times people will put firmware on the device to put it into a shipping mode, as it's called, and that is where the device is not active and not able to be activated until a physical reset of the device happens.
Yeah, and then also from a shipping perspective, so I will tell you, we have we've actually stopped shipping standalone batteries. The restrictions now are very, very strict on being able to basically put batteries or anything related to batteries just by themselves standalone, if you're not used to that. Given that we don't ship battery powered things, so it's not a focus for us. But so please ensure that you understand sort of the shipping requirements from freight companies, FedEx, UPS, DHL, and then for particular countries, because certain countries like Canada have very restrictive policies around battery shipping. So that's just something that you unfortunately you got to go do the research and figure out what you're trying to ship and ensure that you can do that. But LiPo batteries do pose some challenges in terms of making sure that those can be shipped anywhere, in particular standalone.
Yeah, I see one more question here asking, since the new EtherSIM uses multiple carriers, is there a recommended frequency range or tuned antenna type for the antenna suggested? That's an easy one. The EtherSIM can be used in different locations, and it'll be location dependent. So say here in the US, we will use specific bands for the carriers. And so the cellular antennas typically are very wide band, and they'll cover, from the low 700s to 800 megahertz all the way up to about 2 gigahertz, 2.5. Mm-hmm. And so the antennas will typically be tuned for LTE range, which is, may differ from country to country, but in general, an antenna will be tuned to operate across that wide range.
Sure. All right. I think we missed a question. What are your thoughts on emerging SPE standard for communication and power going forward, and how far out are we? Are you familiar with SPE standards?
SPE, Society of Professional Engineering Standards for Communication, I believe. This is something that I think we'd have to mull over and come back with an answer.
Sure. So Llewellyn, please, reach out to us. We'll try to get in the discussion boards. Maybe post that one in there after we're here. We're going to make sure that I won't be available in the chat after this, but hopefully Jackson is. And if not, there's a number of Particle folks and team members that will be in the chats to ensure that we're engaging and helping you get all your questions answered in today's masterclass in IoT. So we are up against it. So Tim, any final parting thoughts for everybody?
Put in that early thought, everyone. Make sure you spec it all out early on and fail early, as the saying goes, because that'll carry you across the finish line with a great product. I look forward to seeing all the great IoT that comes out.
Great. So thanks, Tim. And I'll give a final thank you for joining myself, Kate, if you joined last hour, and with Tim. We are so, as you can tell, the energy around us is, even though we're not in the same room, we're all different places. The energy around Particle is absolutely palpable today and has been for the weeks leading up to this and launching EtherSIM and our new Ether line of products. My team is excited. We are definitely just working night and day to ensure that we have these products ready for you as soon as possible. And with that, I just want to say thank you. We are graciously that you decided to spend time with us as part of your day. So thank you again. And on behalf of Particle, goodbye, and we'll see you next time.